All right, so in today's section, we're going to be solving rational exponent equations. They're not hard to do. It's just you have to know how to get rid of them. And the step is easy. To get rid of them is easy. But it doesn't mean that every example or every question you do is going to be simple to just immediately do this little trick. So I want to show you guys how you get rid of an exponent. Okay, so let's say um, I have something like x to the 2/3. The way I'm going to get rid of it is I'm going to raise it to the 3/2 power. Okay? Notice that's the reciprocal of 2/3, right? I just flipped it. What are you supposed to do when you have a power raised to a power? You multiply them, right? So 2/3 times 3/2. Well, what happens to that? That's x to the what? It's 1. Yeah, x to the first. In other words, it's just x. So the way you get rid of fractional exponents is to raise them to their reciprocal power. So just to show you another one, if I had like negative 1/2 as my power, then I want to raise it to the power of negative 2/1. I'm just going to flip it. That's it. I'm going to get the power. I'm going to flip it upside down. If it's negative, keep it negative. If it's positive, keep it positive. Okay, don't change the sign. Just flip the actual fraction. That gives you x to the negative half times negative 2/1, which is x to the first. Now, I know people will ask me, well, do I have to show the step of the multiplication if I already know that if I multiply something times its reciprocal, it's going to cancel out? No, you don't. You don't have to show this step right here. Unnecessary if you don't want to. Just know, like, okay, if I do this, it's going to make it go away. Now, the key to today is that it's going to have you doing this with equations. So things that you'll see today are going to look more like this. Let's just do a 2/3 equal to 9. Okay? So today it's going to kind of look a little bit more like this. And of course they'll expand on that, right? They'll make it more complicated and stuff. But in its simplest form, it's going to look more like that. So if they want me to solve, then what I'm going to have to do is raise it to the what power? 3/2, right? So I'm going to raise this to the 3/2 power, raise this to the 3/2 power. Now what I normally do, guys, is I just do this. I get rid of that. Because I know that's going to become a 1. When you multiply something times its reciprocal, it's going to become 1. So all I have left is x, and then this is where your calculator comes in handy, because then you can do 9 to the 3/2. Now you can do it by hand too. 9 to the 3/2, that's the square root of 9 to the third. So the square root of 9 is 3, 3 to the third, well that's 3 times 3 times 3, so that's 27. Okay, so this would be my answer. Right, but again, you can put that into your calculator and get the same answer. So it's not like you have to do it in your head. You can just punch that in and get your answer. So notice that is a solution that they want us to find for this problem. So in order to get rid of it, you're going to raise it to its reciprocal power, but both sides, okay? And that's how you do the solving. Now there might be some more things where you might have to add and subtract to both sides first, and maybe divide by something on both sides first to clean it up. But once we clean it up, then we'll just use this little trick, okay? So here we go. So this is very similar to the one that we just did, right? It's just solving each equation. Example 1, p to the 3/2 equals to 729. So what I'm going to do is I'm going to get this equation, and I'm going to raise it to its reciprocal power. Notice it's already just p to the 3/2. There's no like 2 plus p or anything like that, right? There's no 3p where I have to divide it out. Like it doesn't have anything like that. It's just p to the 3/2. So I'm going to raise it to the 2/3 power. Okay, and I got to do that to the other side as well. So 3 halves, the power of 3 halves to the 2/3, that's going to cancel, right? So that's gone. So this is just p. And then I got to find the cubed root of 729 and square it. I don't know what that is, so I'll depend on you guys. The answer is 81? All right, awesome. So there you go. So very simple if the problem is simple, right? Very simple if the problem is simple. But of course, not every problem looks like this, so we'll kind of change it to something that looks a little bit different. So let me show you example 2. Not that this one is insanely difficult, but it does have more to it. Okay, x to the 2/3 plus 4 is equal to 13. So I got to get the x to the 2/3 by itself. That means I got to move the plus 4 over. So when I move the plus 4 over to this side, it becomes a minus 4, right? So this is x to the 2/3 equal to 13 minus 4. That's 9. Now I got to get x to the 2/3 all by itself in terms of x. I don't want that 2/3 power. So I'm going to raise it to a 3/2 power. When I do that, the left side is just x because these will cancel out. Okay, and the right side, well, the square root of 9 is 3. 3 squared comes out to 27. So there's my answer. So, I mean, this wasn't that much more difficult. Just move something over, right? No big deal. Are we okay so far with these? Pretty easy, right? Not too bad. All right, let's make it a little bit more complicated. Our goal here is to get that 3v minus 2 to the half by itself. Because that's the one that has that fractional power. So I want to get that 3v minus 2 all by itself. So that means I'm going to have to move that negative 5 to the left side. Then that negative 3 that's multiplying that parenthesis, I'm going to have to divide it out. Okay? So I got a couple steps to do before I get that parenthesis all by itself. Okay? So let's start off by moving that minus 5. So if I move the minus 5 over, that means it becomes a plus 5. So negative 26 plus 5 is negative 21, right? So negative 3 is left there, 3v minus 2 to the 1/2. Okay. Now that negative 3 is multiplying that parenthesis. So in order to get rid of a multiplication, we divide. So I'm going to divide both sides by negative 3. So that gives me a 7 equals to 3v minus 2 to the half. All right, now notice I have my term with the fractional power all by itself. It could just be an x to the half. It could be an expression to the half power. It doesn't matter. So mine is an expression, 3v minus 2. So I want to get rid of that half power. So I'm going to flip it, right? Instead of 1 over 2, it's 2 over 1. And I'm going to raise it as that power. So it's going to be a power of 2 over 1 on both sides. Well, 7 to the 2 over 1, or in other words, 7 squared, that's 49. On the right side, the powers just cancel out, so it's just 3v minus 2. And now we do a little bit of algebra 1, right? We'll add 2 to both sides and then divide by 3 at the end. So let's go ahead and move this negative 2 over. So that's going to be a 51 equal to 3v. And I know 51 can be divided by 3 because 5 plus 1 is 6, so that's 17. Yeah, 17. So that's correct. So if I divide both sides by 3, I get 17 as my answer. Like I said, the questions might look a lot more difficult. They might look more difficult, but it's basically the same steps you take whenever you guys are solving any other equation. Just try to isolate the fractional power term, whatever it happens to be. So here, my goal was to isolate this piece right here. I wanted to get all of this by itself. Okay, so I had to move everything else out of the way, right? Whereas the previous problem, I was trying to isolate this. I wanted that all by itself. That way I can use that trick of raising it to a power that's its reciprocal, right? Same with this one, right? I wanted to isolate the 3/2. It was already there. It was already isolated. So I was able to immediately do that little trick of flipping the power and raising it to that power, right? So if it's already set up for you, then go ahead and do the trick. But if not, move whatever you have to move, which in our case we moved the 4 there. Here we moved the 5 and then divided by, we moved the -5, we divided by -3, and then we were able to do that raising of a reciprocal power. So here's the last one. Then I'll give you guys your homework. So hopefully you've kind of seen this and saying, okay, homework doesn't look too bad. I hope it's not. A lot of it is calculator based. You're going to have to use it to do this work here. So we have a -3 times the quantity of x plus 23, all raised to the 5/3, minus 9 equals to -9,384. Now I know that's a huge number, but again, you have a calculator, so don't freak out, right? Just make sure you use your calculator appropriately to get the right answer. But this is like the hardest looking problem on your homework, okay? I don't know if you consider it difficult. It's very similar to example 3, so the same idea. All right, so I want to isolate x plus 23 to the 5/3. Right now it's being multiplied by -3. It's being subtracted by 9. So first thing I'm going to do is I'm going to move that -9 over to the other side. Okay, so let me change the pen here because I have a highlighter. I'm going to move that over. So I end up with -3 times x plus 23 to the 5/3 equal to -9,384 plus 9 is what? 300 and what? 75. All right. Thank you. Now, next thing is to get rid of that -3, which is multiplying the x plus 23 term. So I'm going to divide it, right? So divide both sides by -3. So that's x plus 23 to the 5/3 is equal to, what do we get here? 12 and 12 is 24 divided. Yes, this is divisible by 3. I know that. 125, you said?
Yeah.
All right. Now I'm going to notice that my term is isolated now, right? It's x plus 23 all to the 5/3. So I'm going to now use my power principle to raise it to a what power? The 3/5. Yeah, 3/5. So let's raise it up to the 3/5. And then you'll get your calculator again to figure out what 3,125 to the 3/5 is. Because I don't know what that is. 25? Oh, that's nice. Okay. Oh, 125. Oh, sorry. Still nice. Not too bad. So 125. All right. Last step, get x by itself. So we'll just subtract 23. That one I don't need a calculator for. 102. And there you go. One of the nice things about these problems is no check step. Right? You don't have to do a check step for these, so it's kind of nice. All right? How are we doing? Is that one not too bad? Hopefully not too bad. Remember, isolate for your expression, okay? Whichever expression has that weird power, that's the one you're going to isolate. You're going to add, subtract, multiply, divide, whatever you have to do to get that thing by itself, and then you do the raising of the reciprocal power.